Okay, so we're going to continue our study of trigonometry. So we'll start calling it trig, short for trigonometry. And I suppose the big thing in trigonometry is that it's to do with triangles. And at the moment, we're only studying triangles which happen to be right-angled triangles. So let's draw up a nice big right-angled triangle. And we call out the right angle there. Okay, now we already know the name of one of these sides, okay? And that's this thing over here. This was yesterday's lesson, C. Remember we were putting C in there because that was the hypotenuse. Okay, so that's the hypotenuse. Sometimes it's called C, sometimes it's called the hypotenuse. So when we're talking about Pythagoras' theorem, in the formula tables it's given as a squared plus b squared equals c squared. So that's the hypotenuse. Okay, now if I am talking about this angle down here, so if I'm talking about that angle, do you know something? I'm going to introduce a new letter. And this is a very weird letter because it's not an English letter, it's a Greek letter, and it's called theta. Okay, so our theta is down there in the bottom right hand of our triangle. Now, we need to give these two other sides names. We need to name this guy over here, and we also need to name this guy over here. So we know the hypotenuse is, we know how to find the hypotenuse. But if we're talking about this angle down here, which we are, we're talking about him, the angle theta, the side across from theta is known as the opposite. Opposite, okay? So the side that's across, or the side that's not touching theta, is called the opposite. And that just makes sense, right? Because it's across from, it's opposite to the angle. And then there's another side which is actually touching, which is touching theta, and we call that the adjacent. So if you have a terrace of houses, each house is adjacent to its next door neighbor, okay? So adjacent means beside. So this side down here is the side that is beside the angle. So you will need to know how to find the opposite, how to find the adjacent, and how to find the hypotenuse. So you will need to have those three skills. Okay. Now, it all depends, or rather these two here, the opposite and the adjacent, they depend on where theta is. So let's draw pretty much the same triangle. That's our right angle, so we immediately know that our hypotenuse is over here. And let's say we're talking about this angle up here this time. So let's call him theta. So the angle we're talking about is theta. Well then, the opposite this time will be down here. And therefore the adjacent will be over here. We happy enough with that? Okay, so you need to be able to spot, or how to find, the opposite, the adjacent, and the hypotenuse. You need to be able to do those three things. Okay. So that's that. Nothing too weird so far. Now, the reason why we need to do this is because we're talking about, in a few minutes we will be talking about sine, cosine, and tan. So sine, cosine, and tan. We can call that cos if you want to. Sine, cos, and tan. Right, now, we always take sine, cos and tan of a specific angle. So let's say we're talking about this angle down here. That's my hypotenuse. That's my adjacent. And that's my opposite. Okay, so we always, besides sine, cos and tan, we always put in theta. And these have to be equal to something. And they are always equal to fractions. Okay, so we need to know what makes up the fractions. And the way we work this out is through a mnemonic called silly old Hitler couldn't advance his troops over Africa. Okay, so silly old Hitler, therefore with the S, with the sign, we put in an O and a H. With the C, couldn't, we put in an A and a H. Advance his. With the T for tan, we put in over Africa. So this S here is this S here. And then we move on to the O, which is the O here. We move on to the H, which is the H here. So this is very, very difficult for me to teach this without actually looking at you and thinking, have they got it? So hopefully this isn't the first time you're seeing this anyway. So hopefully some other teacher taught you this in junior cert. So we should be good to go. I quite like this mnemonic. I think this is the one that Miss Collins uses. So I think Fufu, you were in Miss Collins' class, so you would have come across that one before. Silly old Hitler couldn't advance his troops over Africa. S-O-H, S-O-H. Couldn't advance his, C-A-H, C-A-H. Troops over Africa, troops over Africa. Okay, so let's see how this is used. So we're only going to go one way today. We will have to work backwards in a little while. So I'm going to go through an example here. And my favorite example in the whole world. I'm going to say we have 30 degrees there. And that's our right angle as normal. And I'm going to say that we have 6 here. And I want to know the length of this side here. Okay. Right, so the way to tackle this question is to write down what we have and what we need. Okay, so what do we have? We have, first of all, we have the angle. So our symbol for angle was theta. The other thing we have is this 6 here. Now, if we're talking about this angle down here, we call 6 the opposite. Okay? So, hopefully you're not, after witnessing that. Okay. Anyway, okay. So we have the opposite. Now, we need, well, What do we call x again? X, he's across from the right angle. So x is the hypotenuse. Okay, so we go back up to our sine, cos, and tan. I just try and copy them. How do I copy? Let's put them over here somewhere. Oh. Actually, you know what? That's good, isn't it? Okay. So we have theta and we have O, and we're looking for H. So let's take a look at tan. Does tan has theta, it has O, but it doesn't have H. It has an A instead of H. So the tan is no good to us. What about cosine? Cosine, that has, or cos has a theta, but it doesn't have an O or it doesn't have an O. So cosine doesn't deal with the opposite. What about sine? It has a theta, it has an opposite, and it has a hypotenuse. So we're going to use this formula here. We're going to say sine theta equals opposite over hypotenuse. And we're going to change our sine theta. We're going to change theta into 30 degrees. And we're going to change our O to a 6. And we're going to change our H into an X. Okay. Now, we don't really like doing trigonometry. You know, we don't really like doing this sine, cos, and tan. We much prefer just regular old numbers. So as soon as we can get rid of sine 30 degrees, as soon as we can get rid of that, we take the opportunity to do so. So I go sine 30 in my calculator, and I end up with 1/2. So I have 1/2 equals 6 over x. So I now have 1x is equal to 12. Therefore, x equals 12. So I've worked out the length of this side here. If that side there is 6, and that side there is, or that angle there is 30 degrees, well then that's the length of that side there must be 12. Okay, so I'm going to do another question really quickly. You're going to do 3 of these, I think, just to kind of maybe overkill. So again, this is very, very hard to learn from a distance. So let's say, it was quite nice the last time the way it worked out to be a fraction. So let's say it's going to be a decimal this time. So let's pick, I don't know, 41 degrees. And let's say we have, I don't know, 8 on the hypotenuse. And I want to know the length of this side here. Okay, so let's label up our triangle. 41 degrees, that's the angle. So let's call him theta. We know 8 is the hypotenuse. And we know x is the adjacent. So I go sine theta, cos theta, tan theta, equals, fraction, fraction, fraction. Silly old Hitler couldn't advance his troops over Africa. I then write down what I have, what I need. I have the theta, and I have the hypotenuse, and I need the adjacent. So which one of these 3 guys over here, deals with theta, h, and a? Is it this guy here? Theta, H, and A. No, so it's not sine. Is it tan? Theta, A, but no H. So it's not tan. So it must be cosine. It must be cos. So I then write out cos of 41 degrees equals, I can put that in brackets just for my calculator, equals some fraction. And the fraction is A over H. So my A is X and my H is 8. Okay, I don't like doing trigonometry, so I get out of cos 41 as quick as possible. I put into my calculator. In my calculator, I hit cos, and 41 equals 0.7547 equals X over 8. So therefore, X by itself equals 8 times 0.7547. So X equals, sorry, what I did there was cross multiply. So 8 multiplied by 0.7547 equals 6.0376. So X is equal to 6.04 centimeters or whatever. Okay. Right, so that's 2 done. Let's do another one. Let's draw a weird triangle this time. Let's say we have a triangle that looks like that. And let's say this guy here is 7. And this guy here is 8. And, oh, sorry. That guy there is 7. Oof. That guy there is 7. This guy here is our theta. And we're looking for the length of that chap there. Now then, so we write out sine cos tan equals, oh, I forgot something. Sine theta cos theta tan theta equals fraction, fraction, fraction. Silly old Hitler couldn't advance his troops over Africa. I need to make a decision. Which one of these 3 things here do I use? To do that, to make that decision, I write out what I have and what I need. I have the opposite and, sorry, do you know what I'm going to do? I'm going to put in, sorry, I'm inventing these questions off the top of my head. So he should be maybe, I don't know, he looks like maybe 43 degrees, let's say. Okay, so I have theta and I have O and I need X here. He's going to be the adjacent. Sorry, I'm finding this really, really hard to explain on an iPad or on my Surface Pro. We'll see what happens. This isn't great, is it? Anyway, so I then fill it into, I then decide which one of these 3 over here do I have to use. So am I going to use sine, cos, or tan? Well, A, O, and theta. O, theta, but that's a H, so it's not sine. Is it cosine? Theta, yeah, A, but no H, that's no good. So it must be tan here. So we're going to use tan. So we say tan of 43 degrees equals some fraction, 7 over X. Tan 43, I can turn that into a number as quick as possible. So that's 0.9325 equals 7 over X. So cross multiplying, I get 0.9325x equals 7. So therefore X equals 7 over 0.9325, which is equal to 7 divided by 0.9325 0.25, which is equal to 7.5. Okay. So that's how to use these sine, cos, and tan things going forward. Yeah. So I will put up some exercises for you guys to do. And we'll talk again on Wednesday. So yeah, I know this is difficult. It's really difficult for you guys learning this from a distance. Okay, I fully sympathize with you. But hopefully you've already learned this, and this is just refreshing it from Junior Cert. Okay. Okay, so let's leave it there. So I'll see you again on Wednesday, guys, and best of luck.